Okay, so if I wanted to add these a different way instead of changing them into rectangular format, we could work with them in polar format, draw a picture, which is going to give us a triangle. And from that triangle, since we only have two vectors working here, that triangle, we're going to be able to use sine, cosine, and tangent in order. I should back up. You could use sine, cosine, tangent if you have a 90-degree angle, but if not, you can use the law of sines and the law of cosines. You use those laws when you do not have a right triangle. Right triangle, you just use sine and cosine and tangent. So let's draw this. If I talk about my first vector, it's a magnitude of 4 at an angle measure of 20 degrees. You could draw this to scale using a protractor and a ruler and coming up with a scale factor. And you could solve it that method as well. But you got to be pretty precise on your drawings. So instead, we're going to just make a rough sketch of this. I'm not going to be exact, but we have a 20-degree angle and a magnitude of 4. I don't know if that's 20 degrees. I don't know if that's 4, but that's what we're going to let it be. So this is 4, and I know that this is 20 degrees right there. Remember, when you add vectors, you add them head to tail. So what you need to think of is at the tip of that one, we need to think of a new XY axis. And at that new XY axis, we have this magnitude of 7 at an angle measure of negative 230 degrees. Negative 230 degrees puts you in which quadrant? In the second quadrant. And what is that reference angle going to be? $50 degrees. So I'm just going to enlarge that right over here. So I'm going to have this angle that veers off over here, where this is 50 degrees, and this has a length of 7. Do you agree with that? That's probably even actually a better drawing, because I have this force that comes over here like this. Keep in mind, this is 20 degrees. If I look at that, wouldn't you agree that this line right there is parallel to that right there? And what do you know about those two angles? Alternate interior angles. So I know that this angle measure right there is also 20 degrees. Now I'm going to sketch in my resultant, and this is not drawn to scale. I should probably draw this a little bit better because I know where my object's going to end up at. Change the way it comes up over here. And then your resultant is right there. So you have a triangle. Everybody sees that triangle. You know two sides. You know a length of 4. You know a length of 7. And I actually know an angle measure. What angle measure do we know? This one right here is 70 degrees. Okay, so let's figure out what the magnitude is. The magnitude of my force, I want to know, what is that right there? Like, my object feels like it's being pulled at with which amount of force? How can I find that? Well, I have an angle and the side opposite. Do I know any other angle in the side opposite? Because using the law of sines, I have to know a side and the angle opposite of that. And I have to know another side and the angle opposite of that. So I have to know at least a pair. And I don't know a pair. I don't know this. I don't know X, but here I don't know what that angle measure is. It veers off a little bit, and it's not just 70 degrees right there. It's 70 and a little bit more. And I don't know how much is a little bit more. So there's no way that I can actually use the law of sines to find that. So what I'm going to use to solve it is the law of cosines. And in the law of cosines, so to find that, I'll use purple. We're looking for x, which is a side. So it's going to be x squared is equal to what? 4 squared plus 7 squared minus 2 times these two sides right there. So times 4 times 7 times the cosine of the angle opposite. What is that angle measure? 70 degrees. The angle is 70. Now, not always will you know the angle opposite. Maybe 7 was opposite of that. So then my x is going to end up in here somewhere. And the solving of it will be just a little bit. I mean, you got to think about your, then it's an algebraic equation. You got to know how to solve the algebraic equation. Okay, so as we look at this right here, and I want to solve that, you got your calculators. You could type that straight in and across as it goes right there. Just type in, oh, what do you have to do as a last step? As a last square root. Let's do that because you could type it in all the way on your calculator as the square root. Hit your square root key, 4 squared plus 7 squared minus 2 times 4 times 7, the cosine of 70 degrees. Okay, I got to pause this while you type that in. Okay, so when we do that, we get a value of 6.77. That's the force. That's how many newtons. That's how many pounds or whatever. That's the force that your object's going to be pulled at. So right now, as far as my resultant is concerned, my resultant is going to have a magnitude of 6.77. Now I need to figure out the angle measure. Okay, let's back up just a second. I'm going to flip back to some screens to see what we got on Friday when we solved it by coming up with the rectangular coordinate system, and look at what we got right here. It was 6.77, right? So it agrees. It was just another way to get there. Now what we want to do is we want to figure out what that angle measure should be. Well, I can figure out what the angle is inside right now. Let's go with blue. This is the, I want to know that angle right there. That's opposite of 7. So I have 7 over the sine of an angle that I'm looking for. I know that this x right here is now 6.77. So I have 6.77 over the sine of 70 because that's the angle opposite of it. Cross multiply. If you cross multiply, you've got to be careful with this. You cross multiply, you're going to take 7. So I'm going this way here, sorry, which is better because then I'm not standing in front of it. 7 times the sine is 70, and you're going to divide by 6.77. That's equal to the sine of x. Did you type that in? Yeah, what do we have to do though as a final step? If I'm looking for an angle measure, what do you have to hit? Yes, you have to do the inverse sine of that particular value. So go ahead and type that in. They may use their fraction key. Okay, what did we get? 76.3. Okay, we got 76.32. 76.32 degrees. But that's not the answer we had before. When I flipped back on that screen, the answer was what? 96. But if I look at it, my resultant is going from 0 degrees to here. So it's going to be that 76.32 plus the 20 degrees. So I got to add my 20 to that, and that's where you're going to get your 96.32 degrees. And there's your resultant force. See how you can use the law of sines and law of cosines to get there. You could change it into rectangular format. That's what your book is going to tell you to do. But it would be nice for you to get practice doing it both ways. Now, here's something else you can do. What happens if they ask you, I'm going to just keep the same problem up here, and what happens if they ask you for something called, I better move it back up here, but I don't have room up there. What if they ask you for an equilibrant? An equilibrant is going to be what puts that in equilibrium. So if I think about it, I have a force going up over here. I want to change that color, sorry. We have a force coming up over here, which is my resultant. I'm going to exaggerate just a little bit. This is a magnitude of 6.99, right? 6.77, right? So this is 6.77. And then if I look at the equilibrant is going to be, oops, the opposite of that. What do you know about these angles right there? They're vertical angles, so they're going to be equal to each other, correct? If they are equal to each other, this full angle right here was how many degrees? 96.32, which means what's this angle measure just right there? 6.32. So this angle measure right here is 6.32. Equilibrium, it's going to be the same force, right, in the opposite direction. The same force in the opposite direction. So I could state my answer as 6.77 at what angle measure now, though? We're going to talk about 90, and we're going to have to subtract the 6.32, which is going to make it 83.68. There's the equilibrium. Negative 83.63. Thank you. Well, that's really bad. Let me just start that all over right there. At an angle measure of negative 83.68 degrees. There would be the equilibrium. And sometimes they ask for the equilibrium. And it just means what will put it in equilibrium versus the resultant. Like the law of sine cosines? I do. Those of you that don't want to learn something new, you're comfortable with going from polar to rectangular format because you've been doing that since last year. The little polar bears started us off with all of that stuff. Maybe they weren't polar bears, just multicolored bears.